We are going to solve some systems by elimination. This is also called a linear combination method sometimes. And what's going on is, notice I have an equation and an equation. And I could try and do substitution here or graph them, but what I notice is I have a y and a negative y. Now, this whole thing hinges on this is equal to that. And this thing is equal to that thing. So notice, like, if these are the same and those are the same, I can add these together and add these together, and the left side still equal to the right side. I could also subtract. I could also go this bottom one minus the top one, and the left side will still equal the right side. So again, this process is called elimination. So I'm trying to eliminate one of the variables, and I notice I have a y and a positive y. So if I subtract this equation, this second equation from this first equation, that'll get rid of y. Like 3x minus 2x is x. Y minus y is 0. Look at this. 13 minus 11 is 2. I know what x is right off the bat. I can plug it back in and figure out what y is, right? 3 times 2 plus y is 13. Subtract 6 from both sides. Looks like y is 7. Does that work here too? When x is 2, is y 7? Yeah, 4 plus 7 is 11. So my answer is, when x is 2, y 7, I can write that as the ordered pair 2, 7. Great, so this is really convenient, right? When I have an x or a y and a y, when these are both the same. But notice, like on this one, I've got a 5x and an x. Now, I want this x to go away. I could get away with the y, but I think I'm going to make the x go away. But if this is a 5y, if that were a 5y, I could subtract and I'd be in good shape. So I think what I'm going to do is just multiply this equation by 5, right? Multiply both sides by 5. It's still equal to the same amount. It just now becomes 5x minus 20y equals, let's see, 5 times 20 is 105. Now again, this line is equivalent to that line. It's right because it just multiplied both sides by the same amount. And so now what I can do is, now I'll do my subtraction. Now I'll just go this top one minus this bottom one. So 5x minus 5x is 0. Negative 20y minus 3y. Be careful, negative 23y. And then I have 105 minus 36. I might grab my calculator for that just to be lazy, make sure I'm accurate. I get 69. To solve for y here, now I'm going to divide both sides by negative 23. And I get negative 3. And just like before, now what I can do is I can just plug that back into any of these equations to figure out what x is. And I'm going to plug it into both because I want to check it for both of them. And so let's go ahead and do that. So negative 3 goes in the y spot. So I've got x minus 4 times negative 3 equals 21. Negative 4 times negative 3 is 12. And then if I subtract 12 from both sides, I get 9. So I'm just going to check it, make sure it works in this one. Is 5 times 9 plus 3 times negative 3 36? Like, is that actually true? Let's see, 45 minus 9, 36. Yep. So there's my answer right there. I could write it that way. I could write it as the ordered pair. X is 9 when y is negative 3. All right, one more. Look at this one. Like, there's no easy fix here. This is a 3x, this is a 2x, this is a 4y, this is a 3y. But I can make this happen. I'm just going to decide if I want to get rid of x or y. That decision's mine. It doesn't really, either way it's going to work. I think what I'm going to do is, notice I have a 3x and a 2x. If I made these both 6x's, then I could do some subtraction. So I'm going to multiply this first equation, multiply both sides by 2. So 6x plus 8y, and then 18 times 2 is 36. Now notice I did that to make this a 6x. I'm going to make this a 6x as well. So now I'm going to multiply this one by 3. So 6x, and the rest is just going along for the ride. 3 times 3y is 9y, and then I have 14 times 3, which is 42. And now I'm going to subtract. I can subtract in whatever order I want. I'm going to subtract this top one, just so I don't have negative numbers. 6x minus 6x is 0. I wanted that to happen. 9y minus y is 1y. 42 minus 36 is 6. So y is 6. Notice what I could do, plug it back in to both of these equations, figure out what my x value is. So 3x plus 4 times y equals 18. So 3x plus 4 times 6 is 24. Let's see, subtract 24 from both sides. 3x equals negative 6 divided by 3. X equals negative 2. So I suspect that that's true. Let me plug them both into this second equation, just make sure it works. 2 times negative 2, x is negative 2, when y was 6. Does that in fact equal 14? Negative 4 plus 18 does equal 14. So these do work. I could write that as the ordered pair negative 2, 6.